seismic loads, and their effects on buildings. In this video, you will learn about the design philosophy involved in the seismic analysis and seismic load calculation as per IS Code 1893. Seismic-resistant buildings should be designed based on the intensity of earthquakes. So, under minor shaking, the buildings should be designed in such a way that the main load-carrying members in the building should not damage, while other parts may sustain repairable damage. Under moderate shaking, main load-carrying members may sustain repairable damage, and other parts can be replaced after damage. Under strong shaking, main load-carrying members may sustain irreparable damage, but the building should not collapse. As you learned in the previous video. In linear static method, first, the design base shear is computed for the whole building, and then distributed along the height of the building. To calculate the design base shear, refer Clause 7.5.3 from IS Code 1893. Where VB is the total design lateral force, or design seismic base shear. It is the maximum lateral force that will occur due to seismic ground motion at the base of a building. H is the design horizontal acceleration spectrum, calculated using the fundamental natural period. W is the seismic weight of the building. To find the design base shear value, first, we need to determine the value of design horizontal acceleration spectrum, using the displayed formula. Design horizontal acceleration spectrum is the plot of maximum acceleration that will occur during an earthquake and time period of vibration. Refer Clause 6.4.2 from the IS Code 1893 to get the formula. Where Z is zone factor value for the maximum considered earthquake and service life of building in a zone. Refer the map showing the different seismic zones of India in page number 5 from the codebook, and find the seismic zone of your location. Refer the table number 2 in the codebook to find the zone factor value based on your seismic zone category. I is the importance factor used to obtain the design seismic force, depending on the functional use of the building. Characterized by hazardous consequences of its failure, its post-earthquake functional need, historic value, or economic importance. Refer table number 6 to find the importance factor from IS 1893 codebook. SA by G is the average response acceleration coefficient. Refer figure number 2 to find the average response acceleration coefficient value. Choose the value based on the type of soil present in your construction site. R is the response reduction factor. Depending on the perceived seismic damage performance of the structure, characterized by ductile or brittle deformations. Refer table number 7 to find response reduction factor. Choose the value based on your lateral load resisting system used to construct your building. TA is the fundamental natural period of vibration in seconds of a moment resisting frame building. Use the displayed formula to calculate the value of TA. W is the seismic weight of the building. It is the total dead load plus appropriate amounts of specified live load. Refer table number 8 to select the percentage of live load to be considered in the seismic weight calculation. The calculated design base shear is distributed among the different floors of the building. The distributed load should be applied at the column joints in the lateral direction. This completes the video on seismic loads and their effects on buildings. Thanks for watching.